Hi guys, we're going to sum up what we've done over the last 3 days with a problem here. I want you to pause along the way and do the problem with me. So once I ask a question, pause it, try it on your own, and then see if you get the right answer. Right now we're going to explore, is there a relationship between body weight and backpack weight of hikers and how much they're carrying? So the first thing I want you to do is I want you to pause this and draw a scatter plot right now for me on paper, or enter it into your calculator and look at it on your calculator, please. If you need a reminder on how to enter it in your calculator, friendly reminder that you hit Stat, hit Enter and Edit. L1 is your explanatory variable. You're wondering right now, what's the explanatory variable? The explanatory variable is your cause. I use the word cause cautiously. You can only say cause in statistics if you have a well-designed experiment that includes randomization, control, and using enough subjects. I am using the word cause right now because I think it's the easiest for students to understand. Does body weight cause backpack weight, or does backpack weight cause your body weight? It makes the most sense that we can use body weight to predict our backpack weight. Our backpack weight would be the response variable. Those are two terms you do need to know for the AP exam. So hopefully by now you've paused it, you've entered it in L1 and L2. If you need help getting it in your calculator, after that, to see the graph, you hit second Y equals. You hit enter on plot 1, hit on. It's the first little graph that you see, that's your scatter plot, and then you hit zoom 9. If you get any errors, check to see, do you have anything else in your Y1, so hit Y equals. If you get an error that's dim mismatch, you didn't enter something in properly. So just a FYI to look for that. So you can look at your scatter plot, and I just sketched it down below here. Please don't forget that you need your labels. So I have the weight of the hiker on the x-axis. My explanatory variable always goes on the x, and the weight of the backpack on the y-axis. You will be asked to describe the distribution. So I want you to pause it right now, look in your notes for the description of a distribution. What does that mean? You should see the word sets, shape, unexpected, direction, strength. What did I put? I said this shape is linear. The U is there's a potential outlier. There's a lonely guy or girl right here at 187, 30 pounds. So I said potentially the guy or girl, I should have put, who weighs 187 and carries a 30-pound backpack. I put a positive direction, and right now it's somewhat strong. Now, in order to really describe this better with the direction and the strength, we can use the correlation. And the correlation coefficient is one thing that you'll be asked, and it will say, find the correlation coefficient and interpret the value of R in context. So I want you to do that right now using your calculator. If you don't know how to find it in your calculator, you do this. Hit Stat, arrow over to Calc. Let's go down to number 8 and calculate your linear regression there. So you can see you have your A, which is your Y-intercept of your regression line, your B, your R, which is your slope, your R squared, which we will use next week, and your R value, which is your correlation coefficient. And I got my correlation coefficient to be 0.78, I accidentally wrote it down wrong. It should be 0.7836, excuse me. And how do I interpret that now? Pause it and try to find the definition in your notes. Practice writing it. You should get this. 0.7836, which means there is a strong, positive, linear relationship between backpack weight and body weight. You do need to have this memorized. You want to talk about the direction, the strength, and that it's a linear relationship, because correlation is talking about the direction and strength of two variables that are in a linear relationship. The next question I want you to try and then pause, try this question, pause the video, and then we'll talk about it and see if you got the right answers. What effect would removing the heaviest body weight from the data have on the correlation? Justify your answer. So I'll go back up to my picture now. We'll look at the heaviest hiker right here, this lonely person out here. What effect would removing this point have on your correlation? All right, so removing this point, I tried to get some things in here. If I have the point and I do the oval test, you could see it's a somewhat thick oval. If I take that point away and I try the oval test, my oval now gets thinner, which means my correlation increases by removing that point. I still have a linear relationship with the correlation gone, which is a good thing, okay, because correlation describes a linear relationship, and the oval is thinner, so the correlation increases. Here's what I have down for an actual answer. Removing the outlier would increase the correlation since the remaining 7 points are more tightly clustered in a linear pattern. This concludes section 3.1. Now you could continue to be asked questions about this data based on 3.2. And the first question that you'll be asked is, what is the equation of the least squares regression line? Interpret the slope and the y-intercept. You should have it already on your calculator here. Okay, by now you should have written down the equation of the least squares regression line. You can have y hat is equal to 16.317 plus 0.091 times x, but then you need to say that your y hat is your predicted backpack weight and your x is your body weight. I prefer the way I have it here. Now, when we want to interpret the slope and interpret the y-intercept, pause if you haven't done that. You should have the notes, you should have a sentence frame that I gave you on how to do this, how to interpret it the right way. There's some keywords that you definitely need. Here is what I did for the interpretation. To interpret the y-intercept, I put the model suggests the y-intercept is 16.3, which is the predicted value of the weight of the backpack when the hiker is equal to 0 pounds. Now, a hiker can't be 0 pounds, so that's why I put the sentence, this is only meaningful if a person could be 0 pounds, which obviously can't happen. You just need to show the AP reader and anyone else that you know that a y-intercept is the value of your y when x is equal to 0. Now, the slope always is your rise over run, okay? As I'm running across that x-axis by 1 unit, how much am I going up or down in that y-axis? And now you just need to use statistical language. The slope, the model suggests that the slope, 0.09, sorry, I have that down wrong here. 0. We'll just say at this point, because I can't erase it, 0.09. Tells us the amount of the backpack weight in pounds is predicted to change when the weight of the hiker increases by 1 pound. Okay, so the model suggests the slope, 0.09, tells us the amount the backpack weight is predicted to change when the weight of the hiker increases by 1 pound. So you can write it a couple other ways. Just make sure that you say the model suggests and something about it's a prediction or it's some kind of approximation. Next, what we covered is using that line for prediction, okay? So if we're going to use that line for prediction, use that to predict the weight of a backpack for someone who is 187 pounds. Pause it right now and figure that out. So you can do one of two things. You can take 187 right here and just plug it in and just type it in your calculator, 16.317 plus 0.091 times 187. But if you imported it into your Y1, you can use your table function and just type it in and see what the value is. Either way, though, you do need to show your work. Pause right now and do that, please. Okay, so here's what I would expect you to write down. 16.317 plus 0.091 times 187 gives me 33.43 pounds. If you're asked to interpret the value, you would just say for someone who's 187, we predict their backpack weight would be 33.443 pounds. Okay, so now what? Now we talked about residuals. Find and interpret a residual for a person who is 187 pounds and the pack is 30 pounds. This right here, this 30 pounds is the actual value. A 187 pound person carried 30 pounds. But we know that the line is predicting them to carry 33.43 pounds. What I want you to do right now is pause it, find the residual, and then interpret that residual. Okay, so by now you should have at least found the residual. You do need to show your work. We have the observed weight of 30 pounds minus the predicted weight. How did I find that? I plugged 187 into my least squares regression line, and I set that up for you so you don't have to do plug in two different numbers. We just did that in the previous problem. We see that we have a residual of negative 3.443. Now I want you to do your best to interpret it. So pause it right now and then you can see what I have. Okay, so you should have something to the effect that the residual means the least squares regression line over predicted the weight the backpacker, who weighs 187 pounds, would carry by 3.443 pounds. How do I know this? Well, what the prediction is the second value. That's bigger than the first one. I get a negative number, and that means that we over predicted what's happened. So you can always think of it kind of as opposite. If I get a negative number, the line over predicted. If I get a positive residual, the line under predicted. Now, is 3.443 pounds that heavy? So did it over predict it by that much? I don't think so. To someone who's not very strong might think that's a lot. I still think that's pretty light. However, our job now will be to look at all of the residuals and see, is the line doing what it's supposed to be doing? So this is everything that we have covered over the last 3 days, all in one problem. Hopefully this made sense to you. Hopefully it kind of wrapped it up for you. If you have any questions, please write them down and let me know. I'll be happy to help. Have a good night. Oh no. And I can't find my stop button, you guys. Oh, here it is. Ah.